We have seen about the SCD type, right? SCD type relation dimensions, and we have seen about type 1 and type 2 and type 3. Okay, and type 1 is like, as I said, like it's a current records. We maintain a current records. Okay, and type 2 is something like that. It's a current plus history records. Current plus history records. Okay, and when it comes to the type 3, it's a current plus partial history. Okay, so difference between the type 2 and type 3, we maintain the partial history, and the type 3 is the disadvantage is that, so where we have to maintain the, uh, just a minute. Yes. The disadvantage of the type 3 is that for all the descriptive columns, we should maintain them twice. Okay, for the current location, for the previous location, right? Just like that. So for all descriptive columns which are going to be changed, so we have to maintain the two columns for each column, and it should be a high memory utilization of the database. Okay, so that is about the type 3. Okay, and type 6 we have seen, right? Type 4 is something like that. So we maintain a current table in separate table and history table in a separate table. Okay, history records in a separate tables. And when it comes to the type 6, it's a, if you include the type 1, type 2, type 3 in a project, that is called as type 6. Okay, today we are going to see the schemas. Okay, so what is schema? First thing, do you have any idea on schemas? What is schema? Generally, we follow the one, if you suppose, if you are going to build a house, you follow some blueprint, right? So you will have some structure in, like how like the construction, the doors, where it should be there. Okay, how the facing of the house should be there. Okay, and where should be a hall, and where should be a bedrooms, and where should be kitchen. So these type of this structural thing will be represent in the logical way. Okay, so even if you see go the, it's like if you know like a vastu, right? So they will look into the perspective of the vastu, like where should this house room should be there and all those things, right? So that is type of schema when you go to build a house. Okay, where it comes to the data warehouse also, we have a schemas how to have a relation between the dimension and fact tables. Okay, based on the relation between the dimension and fact tables. So and where we have to be like, if you like, if you use the confirmed dimension, we have a dimension which has a multiple relation with the fact table, and there is no change in the fact dimension tables, right? So these type of things will be take care of while having the schemas. Okay, this is just like a, we can say it's a logical representation of the database. Logical representation of the database. Okay, so we have a three types of schemas available. One is star schema. Okay, and the second is snowflake schema, and third is galaxy schema. Okay, so star schema, snowflake schema, galaxy schema, and star schema is something like that where we maintain where the dimensions are having the relation between the fact table, relation with the fact table. Okay, and it should not, the dimension should not split into the multi dimensions, multiple dimensions. Okay, that means dimension will not have a child dimension. Okay, will not have a child dimension. Where it comes to the star schema, snowflake schema, the dimension will have a Dimension will have a relation with the fact table, but the dimension, right? Dimensions are going to split into multiple dimensions. Okay. And the relation diagram for the star schema is looks like a star. Okay, that's why it is called as a diagram of star schema. It's look like a star. So that's why it's called as a star schema. Okay. And this fact and dimensions are going to split into multiple dimensions. Okay. This is called as snowflakes. Galaxy schema is something like that. If you are using in a project both, okay, star and snowflake schema is known as a galaxy schema. Okay. So what is the example? Okay, what is the example of this star and snowflake and galaxy schema? We'll see now. Okay. I will go and let you know. Okay. Right. So now I'm going to take one tables like electronic goods. Okay. We'll have a 4 dimension tables. And these 4 dimension tables have a relation with the fact table. It is centralized fact table. Okay. And the relation will be like this. So what are these 4 dimension tables? We'll see each and every dimension. This is the dimension table where it is like you can say like a mobile dimension, dim mobile. Okay. Dim mobile. Here we will have a in dimension we will have a keys, right? We will have a keys. So what are the keys are like? So mobile key, and next is a business phones. Mobile keys and business phones will be there, and general phones are yeah, general phones, whatever. Okay, general phones, whatever. We will have other things. Okay, like this. So this is like a dimension table where we have a dim camera in camera. This is the camera dimension. Here we'll have a camera key. Camera key is the important one. Okay, and also we'll have the camera key, and the cameras can be like a basic camera. Okay, basic camera, and what I like we have like some other cameras, right? So we might have seen like whatever that didn't remember the name. Just a matter. Okay, fine, like HD camera, whatever the cameras, we have a different type of cameras here. Okay, fine. So this is what the dim camera, and the camera will have a whatever camera key and mobile. And here we will have a dim washing machine. Okay, dim washing machine. This dim washing machine will have a washing machine key, and the washing machines can be like we will have like a top load and front load, right? Front load. So these are the things, types of washing machines we'll have. So this is like dim laptops. Okay. So this dim laptops will be like what? Like it's a laptop key, and We'll have a laptop key, and laptop can be like gaming laptop, right? Gaming laptop, and also what is that? We can say other laptops like general basic laptops are also there, right? Laptops. Gaming laptop will be have a business laptops will maintain. So like different type of laptop there. So these are, if you see, these are all electronic goods, right? Electronic goods. So this fact table is known as a fact electron fact electronics. Fact electronic is the table. Here we will have a columns like, see here we have a mobile key because it's a foreign key here. Okay. And camera key. Okay. And here we'll have a washing machine key. Washing machine key. Okay. And also we have a laptop. And as of also like in a fact table, we need to know, we need to have total units. It's a fact. Okay. Total units and the price. These are the columns should be available in a fact table. If you look at this diagram, see it's look like a star, right? So where the dimension tables are splitted, the dimension tables are having a relation with the fact table. Okay. And these are like all the dimensions are, it's do not have any child dimension here. Okay. And all fact table will contain all the keys of the dimension table in the fact table. Getting right? Getting right?
Yes.
This looks like a star. It's an example of the stars. Okay. Just go with the example. If anyone wants to know like what is the star schema, just go with the example. Okay. So here, like if you take any dimension, it will not going to be split here. And this has the relation. And we are having all the data of the dimensions, all the data of these different machines, right? Different electronic goods, right? We will have all the distributed data in the dimension tables, and in a fact table, we have a that total units and price of the each dimension. Okay. Now we'll see what is star schema. What as I said, like a star schema, a dimension is going to be split into the child dimension. Okay, a dimension is going to be split into the child dimension. Then that is called as a a snowflake schema, right? If you see, can we split from this dimension table into other dimension table? Any of this dimension can be split. Can have a child dimension from this here. Any of the dimension.
No, I think.
Okay, fine. So see, if you go
Right, right.
with the, sorry,
Is it right, right?
which one? What do you say?
Like you are asking that we are not able to get that any key.
No, no, no. Can I split of any dimension table into two dimension table,
No, no, no.
right? So just here like washing machine, right? Washing machine can go for, or else we can go with the, just a minute. I did something wrong. Okay, fine. So sorry, I just got a call. Okay. So if you go with the mobiles, right? So in a mobiles, can we have a the dimension like types of mobiles, right? We can split this dimension here. Like we can split this dimension into other dimension table. That is, a mobile can be smartphones or basic phones, right? Here the mobile can be split. So dim mobile, right? Dim mobile, okay, dim mobile, and which has the uh, types like we have a smart key, smartphone key, okay, and this is the smartphone key, and in a smartphone key we will have a like what like other like totally whatever like whatever the smartphone type and OS type you can say here OS type. Okay, we can have this type of the columns available here, and we can split this dim dimension table into other dimension table. So now we have to maintain the key of the dimension table here. This is here we have to maintain a key of the smartphone key like this. Got it? So like this, we will have a keys. We will have a keys and we will have a relation. We will split the dimension table into two dimension table. This dimension table is this schema is known as a snowflake schema. Okay, where the dimension tables are going to split into the multiple dimensions. Okay, and these dimension, the parent dimension will have a relation with the fact table. Okay, this is known as a snowflake schema, and this is also known as a normalized dimensions, where dimensions are going to split into the multiple dimension, right? That is known as a normalized dimensions. Normalized dimensions. So you will get a question like, what is the difference between the snowflake and star schema? Okay, what is the difference between the snowflake and star schema? Star schema will have a dimensions where those are not split. Okay, and we can say like dimensions are in the star schema are denormalized. Okay, and where it comes to snowflake schema, we will have a normalized dimension in the snowflake schema where the dimensions are going to split. Okay, so according to this, right, which one is like better when you go with the performance side? Which one is better? So data where is always focused on selecting data. We have to read the data. Okay, so read the data. If dimensions are going to be split into the multiple dimensions, that means we have to join the all the dimensions. Okay, all the dimensions. Then we have to join the fact table. Then retrieving a data by joining the multiple dimensions will lead us the problem to get a data, right? So each and every table it has to go and look for the matching records, and it will has to fetch the records from the dimension tables, and it has to show us. Okay. So that's why the basically the data warehouse is generally focusing to build a normalized database on data warehouse only. Okay. That is how the selecting a performance will be improved. Selecting a data from the data warehouse will improve the performance. Okay, so this is a normalized database. Sorry, normalized dimension types. So this is how the example of the snowflake schema. Now, if you go and look into the stars galaxy schema, right? I'm going to have a one more fact table, and I'm removing this. I'm removing this here. Okay, I'm removing this relation from this dimension table. And this fact table will have a, this is one more like fact electronic. Okay, this is the one more the fact table, which is a fact electronic, fact electronic uh, 2, something like that, electronics 2 or something. Okay, so here we will have a relation with of this camera, dim camera to this fact table, and this has the like we'll have a key of the camera key here. The camera key will be removed here. Okay, the camera key will be removed here because it has a relation with the other fact table.
Hmm.
Okay, so this is then going to be removed here. Okay, now and also we will have a relation from the this dim laptop. This dim table can have multiple can have this dim table can have multiple relations. Okay, so this has a here also we will have a laptop key here. Okay, laptop. This also we will have. This is a possibility, right? We will have a one dimension can have a relation with the multiple factor. Okay, that is called conform dimension, right? So now we'll have a total units also here and also price. Okay, total units or quantity we can say. This is also a price. Now if you look at this diagram, okay, if you look at this diagram, if you separate out this thing, it's look like a star schema, right? The dimensions are having a relation with the fact table, and it is the dimensions are not split into the other dimension. Of course, the dimension can have a relation with the other fact table, but not split into the dimension table. Okay, it does not have a child dimension. So this is called as a star schema. And if you look at it into this perspective, this is called as a snowflake schema because here the dimensions are split into the multiple dimensions. Okay. To look at this entire diagram, this is called as a galaxy schema. Okay. This is known as a galaxy schema. This is how the galaxy schema will work. Okay. In a project, right? So, see, we generally in a organization, right? So, when we go with the uh, projects, so generally we follow the star schema only. So, there is a very less project into the snowflake schema, and galaxy schema no one use. Okay, there is a very less priority on the Galaxy schema because it's a highly complex project if you are going with the Galaxy schema. Because where some dimension tables are having the relation with the fact table and some dimension tables are other dimension table, if you are going to retrieve data, so there will some confusion to get like how to join the tables and however the data are going to be duplicated in some cases. Okay, so as I seen, right, so I have seen one project that where it is following the snowflake schema. So when generally in a database data warehouse, we always use a fact table as a base table to join the other dimension tables. Okay, but here the dimension table is will be become as a fact dimension table is become as a base table to join with the other child dimension table. First, you have to join the fact table to dimension table, then this dimension table to the this dimension table. So it generally the join will not work like this here. Okay. So that is what like if anyone asks you like in an interview, right? So what is the schema you followed in your project or something like that, sir? So you can tell them like we are following the star schema only. Okay. Where the dimensions are not going to split to the child dimension, and we have only the dimension and the fact relationship. Clear?
Yes.
Okay.
Uh,
Yeah.
can I
Tell me.
ask one thing doubt? Like
Yes, yes.
insta like in snow in second one like dimension has split it into two multiple, right?
Yes, yes.
So on first on dim mobile we are there is a key called a smartphone key, right?
Yes, yes. Yep.
We are taking the we are getting that reference into dim mobile.
Exactly.
So in there is a in dim mobile there is a smart key there is a key called smartphone key, right? Is that
Yes.
we are getting that into fact table or
No, no. It will
no?
not available. That is the problem. Like, see, if this smartphone key is available in the fact table, so it will have a direct relation to the fact table, right? What is the point of having the relation with the dimension table,
Okay. So it will
right?
be it will be like star one only, right?
It will be going to be star only then,
Uh-huh. Okay,
right?
got it.
So, but for the mobile only, if you
Mm.
have a two tables of dimension table and having a relation with the fact table, it's not correct, right?
Mm, yes, yes.
Right. So
Yeah.
that is why. So they want to like see the data into the like in a normalization. I will explain you about the normalization so that you will clear in the next class. Like okay, so normalization is something like that. We don't want to duplicate the data. Okay,
Mhm.
we don't want to duplicate the data in a separate. So suppose if you take, I will here I will explain you in a brief manner. I do have one employee table. And here I have employee and name and salary. Okay. And what is like phone number and location. Okay.
Email ID.
And DPD. Okay.
Okay.
Whatever that, those are all the discrete data. Here we have a department number. And this employee, so I'm not writing all this data
Oh,
distributed.
okay.
So here is employees into the department of 20, this related to the, so again, like I will have a one more column here, DBT name, and he has a Java department. Okay, later this employee has some improvement in technical side, he learned outside and he had some hands-on experience and same. He moved to the other department that is called as ETL. If you see, just an employee, he moved to the other department, but this all the data is what is happening? Repeated, right? The
Yes, yes.
entire data is going to be repeated.
Uh,
Okay, so this is what happened whenever the employee has a some part of that his data is updating, so other columns are going to be updated again and again.
mm,
We are maintaining the duplicates of this data. So because of the two columns, we are maintaining the duplicates of the four columns. Okay, this is what like instead of this, if we are going to split this table into other table, and this is called as a department table. Here, if I do have a one more column, so, so it is not going to add, sorry. Yes. If I'm going to add a one more column here, what is happening? That is called as employee ID. Okay, and I'm just repeating the employee ID is here. Okay, and this employee ID maintains the only one record. So whether if the later if we change the department, so whether we are repeating this data, no, right? We are
no.
maintaining the same data here.
Uh,
This is what is called as a duplication of data, redundancy of data. We are removing by splitting the table one table into the multiple tables. Okay, this is called normalization. Actually. Okay, this is what like happens in the Snowflake, where we have a multiple data again, like why like see here, if we have a other, later we have a other like location table. Okay, location are going to be split. Okay,
mm,
location as location ID and location name. Okay, and area code or something like that. And later we split the employee table into the location table and department table, three tables are become. Okay, like then we have multiple tables are going to be split in a normalization form. That's fine. Inserting the data, so like means we are not going to maintain a duplicate records, that is fine. But when you are going to selecting the data, so you have to combine those all three tables, right? And again, the data should be is seen the all the three tables to fetch the data. That is the problem. So the data warehouse specifically designed for the selecting a data, not inserting, update, delete operations. Right, insert, update, delete operations will be happens only once in a time. Okay, like in a day, like if you see like in a night, after there will be some downtime of the every application, you might have seen. Okay, so you will get a downtime of the every week of the Citibank, other bank, you will get some date, some messages. Okay, or every month. That time what they do, they will stop the entire system and they will load the data into the data warehouse at a time. Okay. Then once they load in the data warehouse, they will start picking the data. They will start picking the data from the data warehouse. And thus this application data will be going to be run again. Okay. So whatever the data is coming in the data warehouse, they will start the analysis. Okay. Suppose simple example is that if you see, if you go with the credit card, okay, credit card bill will be come in the like 23rd, right? 23rd, something like you will have some one date of the uh, credit card bill generation. In the 23rd night, right? So it's before 23rd night, right? 22nd night, the jobs will be loaded at a time. Data will become. And based on the data, you will get the state. Okay. And the statements can be, you will have a data of the statement. So not only you, right? So there will be multiple customers there. Hundreds of customers are there for the same credit card having the 23rd of statement date. So for all the customers, the data will be retrieved multiple times. The retrieving will be happens multiple times. The insert will happen only once. For that why the data warehouse mainly focus on the building a data warehouse with the only denormalization form. Got it?
mm. Yes.
Here is also like why I'm saying the when we work with the star, what are the schema you worked on? We are working on the star schema because the data warehouse focus should be it should not be should not be a normalized. It should be a denormalized. Even though we maintain the duplicate, that is fine because there is some data has changed and retrieving will be easy. Okay, so we are doing the retrieving multiple times. That is why we have to make sure on this retrieving should be easy. That is why so we are making it as a project as a task schema most of the times. Got it? Clear, right?
Ah, yes, yes, no.
That is what like schemas. Okay, and after the schemas, yeah, we have almost completed the data warehouse concepts. Okay,
Mm.
so with this we will end up this data warehouse, and from Monday I'm starting the informatica in that other class, right? So from the 7:50, so you can join that in that class, and we'll go with the informatica part. What is the ETL tool, how the ETL tool, and we'll swing into that some development part also in the ETL side. Okay, and later we will see what is our role in the, as a tester in the ETL testing for the Informatica. Okay,
Okay.
clear?
Yes.
Any questions in a data warehouse thing now?
Mm. No, about that normalization, denormalization, only it was clear. It's clear.
Yes, it's clear, right?
Yes.
Okay, so that is what like see thing is that so in general like whatever the application we are doing every day we are going to do some transaction application level. So they are mainly focused on the inside update delete operations.
Mm.
But when it comes to the data warehouse, we only select the data. Okay, so even some interviews, right? They will ask you. So we have a applications, right? We will go and enter into the database. This is an application, and we enter the data into the this database. So why can't we use this data only for the analysis from here, right? Application of data is going to be entered. And from here to here, doing the learning of staging and staging to the data where there we do the some analysis. Why can't we use this data is going to be, why can't you only this data? Why we are doing all this ETL process? We can use of this data, right, to further analysis,
Mm. Yes.
right? The problem is that, see, now today, and I want to analyze on this application. Today also, we will have a lot of insert operations like insert update delete operations will be happening. Okay, if
Yes.
I am using credit card, today is my bill generating date. Today also you have utilized your credit card. The transaction will be keep on coming, and if you are going to fetch the details from here, like so, insert update delete operations will be happen multiple times, and you are same time you are triggering the reading the data from this table. This database can be going to be like a performance issue, right? So sometimes
Yes.
you might have seen in a what the book my show if there is like a new movie of a big hero movie release, right? It will be like hang in sometimes like in a Bahubali movie release, right? That time you might have seen. So you are not able to book a ticket that time.
Uh,
The number of fittings are high in the database side, and same time the number of retrievings is also become high. So database became it's not that much capacity to handle those many hittings.
mhm.
Okay. The same case, the OLTP case also same thing. And inserting is also happening and retrieving is also happening and reading the data is also happening and your analysis is going to happen. So you can't do the correct analysis, right? There will
Mm.
be some mismatch. There will be the incorrect analysis will be happening the if you take the same data. Of course, if you take from this here to here, like 2022, 2022 to 2023 data you took and you are doing the, some analysis, that will be fine. You can analyze. But every day what happened, you can't release, right? You can't do the analysis correct thing.
Uh,
And you can't make decision correct. That is also one more thing. Okay. This is why so we are going to build a database. And that is why like the opportunities of in a data warehouse and ETL testing will be very high because every business has to be some analysis, whether it is profit, whether it is loss, and what everywhere is the things that we have a scope to improve. Okay, so whatever is going right, we got some profit, even though we have some scope to improve. Okay, that's why some branded showrooms, even if you go with the iPhone, right, it has a lot of profit, but even though they are going to analyze the data because they want to go into the people, the some even like if you see in India, like some every 10 members only one person is using iPhone. Why not nine people are not using iPhone? They want to analyze, they want to go with the customers, right? So that
Mm.
is what like happens in the every business. So that is why data warehouse is very important for every organization, every business. Okay, that's why we have a huge opportunities in ETL trading. Okay, of course the tools are different, but the concept is same. Fine.
Yes.
Okay then. Okay, that's why today for this, so we meet on Monday. Okay,
Mm-hmm.
we'll start with the informatica.
Okay.
Okay, we can catch up on 7:15 catch class. Okay.
7:15 to 8:15 or 8:30? Like what?
8:50. 8:50. 7:50 to 8:50. Mostly I will complete by 8:05. Okay.
Okay, sure.
8 to 8:05. Okay,
That's fine
fine.
for me. Yes.
Okay, Pradesh. Thanks. Okay. Have a nice weekend.
Yeah, you too. Thank you. Bye.